This is Wisconsin Sea Grant students as scientists. We feature a variety of different scientists throughout the school year. Ashley Lemke is with the University of Wisconsin-Milwaukee, and she is an anthropologist. And I'm going to stop there. And again, apologies for not having the formal introduction for you, and let Ashley go ahead and share her work with us.
Okay. Do you just want me to talk for like 15 minutes or so, Ginny, about the work?
Yep, and if you have slides to share, you should have the ability to share your screen if you'd like to.
Great. I am just gonna chat actually to start with because I really want the opportunity to talk to you all, the students and teachers, and see what questions you have. But I'll just tell you a little bit about the work I do. So I am an underwater archaeologist. So I am someone who is very interested in the past. When I was a student, I was always really curious about history. Like I wanted to study ancient Greece and ancient Rome and travel and, explore these kind of far off places. And I went to school to be an archaeologist and got the opportunity to start doing underwater archaeology. So archaeology in general is the study of the human past through material remains. So I don't work on dinosaurs, although that's what people tend to think. And we don't study aliens or UFOs, right? We're really interested in human history and what was going on in the past, what people's lives were like, what their cultures were like, how they lived their day-to-day lives, what kind of technology they had. So I work on exploring the human past as it's preserved underwater. So when we think of underwater archaeology, a lot of people might think of shipwrecks. Like many of you have probably maybe seen one or looked at shipwrecks in museums or have definitely learned about them in class. There's very famous shipwrecks all over the world, things like the Titanic, right? That are really interesting, and they're amazing, amazing time capsules that will tell us about the past. And these boats preserve evidence of, people's lives living on them. But what I do is far, far older than shipwrecks. I study what we call prehistory. So before there were written records that have been preserved, when we don't have photographs, we don't have newspapers, we don't have any of that. It's prehistory. It's back many, many, many thousands of years ago. And at the end of the last ice age, around 10,000 years ago, the Great Lakes were actually much lower than they are today. So all the lakes, you can kind of think of them as being shrunk. There was less water, which meant there was more land. And prehistoric peoples were out on that dry land, out on the old shoreline, just like where we're on beaches all the time today. Their beaches were just further offshore. And they were living there, they were hunting there, they were making tools, they were exploring their landscape around them. And that's the kind of research that I do. So I've worked in Lake Huron for about 12 years to explore submerged sites from caribou hunters 9,000 years ago. So 9,000 years ago, way, way, way back at the beginning of the Ice Age, there was dry land in the middle of Lake Huron, and people were using stone structures to hunt caribou specifically. So Ice Age animals. And we know that they were doing that because we use scuba diving and underwater robots and sonar to map those ancient archaeological sites that are preserved on the bottom of the lake. And we know that they were really, really, really good hunters. They knew animal behavior really well. So they would channel these animals into specific areas, kind of just like you do hunting today. People have been doing that for a very long time, 9,000 years ago in the Great Lakes. And there's stone artifacts that are on the bottom. And one of the coolest things about working in the Great Lakes is they're very cold and very fresh, right? So we have cold, fresh water in the Great Lakes. And that means that some ancient artifacts, things that are organic materials, things like trees, are perfectly preserved on the bottom of the lake. So there are 9,000-year-old trees that are still rooted in the ground that are on the bottom of the ancient Great Lakes. And we can look at those trees, we can take samples of them, we can radiocarbon date them. That's how I know that the sites are 9,000 years old, because you can get a date from that material. And most of the places where I've worked on land, you don't have that kind of what we say preservation, right? A lot of things like wood deteriorate over time. They don't preserve. And the cold, fresh waters of the Great Lakes like keep everything kind of intact for us. So as archaeologists, that's like fantastic because we have way more data than normal by looking at underwater. It just preserves those artifacts much, much better than anything on land, which is really good. So in terms of the research, that's what's going on. I'm going to send you, I guess I could share it. I have a couple links to share that will tell you more about our work. I think some of the really neat things with new research I'm doing in Lake Michigan is I'm actually working with a lot of students in middle school and high school, and they're building an underwater robot for me. We're working together on a team to use a robot that they've designed and they've built and they pilot to go and explore and look at archaeological sites underwater. So I actually can't share it, Ginny. I just tried to do it, but I'm just going to put links in the chat so you all can see some pictures of the robot and the work that we're doing in Lake Michigan. But just like a little bit more, I'm happy to answer like any questions you all have about like what it's like being a scientist, what it's like working in the Great Lakes. I've worked offshore in the Atlantic Ocean and the Gulf of Mexico too, so I've done underwater work kind of all over the place. Um, and I can tell you a little bit too about school. Ooh, I already have a question. LiDAR. So someone in the chat asked if we use LiDAR or do I use LiDAR. In my research, I haven't used LiDAR, but archaeologists do. So LiDAR, if you, those of you who are not familiar, is light detection and ranging. It's basically shooting lasers at the ground and it gives you a really good three-dimensional map of the surface. And the really neat thing about LiDAR is that laser penetrates like forests and trees and vegetation on the surface. So you can fly a drone or you can fly a plane over a place that you're trying to map. It shoots the lasers all down at the land. And then in the computer, you can digitally remove all of the vegetation, like all of the trees and all the plants, and then you can see that land surface below. So they use LiDAR a lot to do archaeology in like the Yucatan Peninsula, like to do Mayan archaeology because there's a lot of rainforest. And you can use the LiDAR to kind of penetrate through the rainforest. Some people use LiDAR to look at shipwrecks. So in shallow water, if there isn't a lot of light reflecting off the water, so if you have a pretty calm day and you have shallow water, the LiDAR can penetrate deep enough that you can map some shipwrecks with LiDAR. But most of my research is sonar. So instead of using lasers, like LiDAR uses, and instead of using light, which is like what photography uses, right? So if you take a picture, you're using light to kind of generate an image. Sonar uses sound. Sonar uses sound just like a dolphin, like echolocation. It bounces the sound off of different surfaces and then it bounces back at a different strength. So we use a lot of sonar in the Great Lakes to map the surface of the lake and then the archaeological sites that are there. It sounds like I might have screen sharing now. Let me share real quick. This screen, which you should be seeing. I can put this link up here too for you all, but this is a website that is for my new project that I'm working on in Lake Michigan. So the plan is to see if there's similar sites
Excuse
in
me,
Lake
Ashley,
Michigan.
we're
Yeah.
seeing your home screen rather than what you want us to
Oh,
see. So
okay. You
try
can see
again.
my messy desktop. Apologies for that.
Yes.
You're like, yes, please stop sharing that. Stop share. It's because I have dual monitors, I think. Okay, what do you see now? Do you see a website, Our Lake, Our Science?
We do now. Thank you.
Great, thank you. So the plan is, right, community science in Lake Michigan. So what was life like for people at the end of the last ice age? You know, who were the first people to enter the Great Lakes region? And to see if there's archaeological sites in Lake Michigan. like there are in Lake Huron that myself and many others, like we have a big team of researchers that have been working in Lake Huron. This is our work in Lake Michigan. So these are some of the students that built the robot. This is the robot.
And again, we're
Um,
seeing your
oh, it's
home
because I'm moving it.
screen.
I'm sorry. I'm sorry.
Yep.
There you go. Those are the students and the robot. And then this was, I'll put the link in here too, but it's just a little bit more about the team and like the current research that we're working on. And the ship, the Lake Guardian, that's how I met Ginny. Just this summer, I went out in the middle of Lake Michigan with a really great crew. We went aboard the RV Lake Guardian and we started doing some mapping of what is called the Mid-Lake Reef. So it's the middle of Lake Michigan. That would have been an island back in the day around 9,000 years ago. And so there's some educators that went out that were on our team. We were called the Lake Bed Landscapers. And they helped map, do some of the very first sonar mapping for the new project looking for ancient archaeological sites. So, oh, hi, Rob. Rob, that's on the call, actually was one of like the lake bed landscapers that was there. So I'm just gonna tick through like some of the questions that are coming in. What is a field day like for you? This is a good question. I absolutely love being in the field. This is my office, so this is not a field day, just to give you a sense of what like life as a professor or life as a scientist is like. This is my office. This is where I am a lot of the school year. So I teach classes, I'm in meetings, but in the field, usually if we're going offshore, so if you're working underwater, you spend a lot of time checking the weather before you go anywhere because you want to make sure that you have very good conditions to be safe and to conduct the type of research that you want to be doing. So we look at the weather days and days and days in advance. And then we usually get up really pretty early, but it's all dictated by the weather. So if it looks like it's going to be flat, calm seas at 2 a.m., we leave at 2 a.m. You have to be very flexible in the field because it's very what we say like weather dependent, right? It's all based on the weather. If you have good weather, you just need to go. Particularly in the Great Lakes, weather can change very fast, and we don't get a lot of work days on the lake. So you leave really early, so it's usually early days. And then to give you an example, like this summer, what we were doing side scan sonar mapping. So you would put the sonar in the water behind the boat. It has a cable that attaches it to the interior of your boat to your computer where you're seeing the data arrive in live time. And we do what's called mowing the lawn, where you just drive back and forth and back and forth and back and forth like you're mowing your lawn. And you're getting a sonar image of the lake bed of the bottom to see if there's archaeological sites there. So a typical day is waking up pretty early, usually checking the weather, using sonar, being out on the boat, working with a big team, and then working as long as you have weather. As long as you have boat fuel, as long as you have time, you just keep mowing the lawn for as long as possible. So that's kind of what a field day is like when we're working offshore. Oh God, guys, these are such good questions. Have you ever found something you were not able to explain? Ooh, good one. We have a joke as archaeologists that if we find something and we're not sure what it is, we just say it's ritual. Like it's something that people were doing that we're not sure. It's symbolic. This is gonna sound kind of funny, but I've explained everything I have found to date. So it doesn't mean that there aren't mysteries. It doesn't mean that there aren't surprises, pretty big ones. So in working in Lake Huron, we found these tiny, 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 they're like this big, two little small pieces of stone tools. And they were black, they're kind of shiny, they're this really thin, sharp material. And those two pieces of rock are volcanic. So they're obsidian. Obsidian is a type of volcanic glass, but people in the past used it a lot to make stone tools. And there's two little flakes that are obsidian that are in the bottom of Lake Huron at these 9,000-year-old archaeological sites. But you all know there's no volcanoes around the Great Lakes now. So we had to use a lot of different laboratory techniques to trace those rocks to their original source. Where did these rocks come from? And they came from Oregon, the state of Oregon, which is way over on the west coast, right? So those two small pieces that we found, they tell us that people in the past, like before social media, before cars, before airplanes, before horses, they were traveling and trading back and forth across the entire continent. And that we were able to explain it by putting the pieces together, but it was a huge mystery to solve and a big shock to our team because nobody knew that people in the Great Lakes 9,000 years ago were trading these materials with people from the West Coast, right? This is at the end of the Ice Age, but people had these connections across the country. So that was something that we couldn't explain it initially. Like, why is there volcanic glass here? There's no volcanoes. But in working with a big team of scientists and researchers and using many different techniques, we were able to find out where they came from. Um, doo, 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 doo. Rob says, I've been brainstorming ways to side scan the Bay of Green Bay without a large vessel by partnering with local boaters and fisher people as volunteers. They will not be able to do the whole day, but maybe a piece at a time or the long time. Have you ever tried an approach like this? This is really good, guys, for learning how science works. So I always say that archaeology is a team sport, and it kind of is. Like you're like, I'm never by myself. I'm always with students, or I'm with other researchers, or I'm with student researchers, or you're working with other kinds of scientists on a project and volunteers a lot. So Rob was on the crew. You can actually still see his picture on the screen. Um, and this is a really, really, really good way, Rob, to do this, to work with volunteers. So anytime that you have an interest about the world around you, like reach out to scientists. Like, this is so cool that I can talk to you guys today because there's lots of opportunities to get involved. Like, these students are building robots for us. And absolutely, if there are people that want to help out, that would be wonderful. Like, kind of like, I'll bring the side scan and then we can borrow their boats and we can work together. I've worked with volunteers before, not so much underwater, but on land a lot. So I think that would be really great if there are people that want to get involved. Um, I'm just gonna keep taking through these. Jenny, let me know if you want me to do anything else. Do you only study the Great Lakes? Have you always wanted to be a scientist? I do not only study the Great Lakes. This is where a lot of my research is today. But last summer I was in Serbia. I've worked in Germany. I've worked in Spain. I've worked in Romania. I've worked in Alaska. So I've been really fortunate to get to travel all over. From my research, I'm very interested in what we call hunter-gatherers. So people who lived in the past that weren't farmers. They didn't have agriculture. So before domesticated plants. That's the time period I'm really interested in, and I go anywhere those folks are. So anywhere there's an archaeological record of people before agriculture, like I will work there. I'm leaving tomorrow to go to Germany. So there's a lot of travel that's involved in being an archaeologist. But the Great Lakes are my personal favorite right now. There's so much to explore here. Like there's so much of the Great Lakes we don't know yet. So it's a really exciting place to be working. I don't know if I've always wanted to be a scientist. A scientist, I think for me was like the hardest like term to accept because I grew up thinking that scientists were like physicists and chemists, who were working in laboratories with lab coats and goggles on all the time. And scientists are so different. And this is why Ask a Scientist, I think, is such a cool program that Sea Grant does because we're all really different people and all of our science is really different. Sometimes I'm in an office, sometimes I'm in a lab, a lot of times I'm in a boat, and sometimes I'm underwater. So I've definitely always really been like a geek and always really been interested in the past. And then the science part, I think like came to me later. Um, when did you start being an archaeologist? So I've had it in me always, I think, but in terms of like my education journey and when I was like official, I went to 4-year college, right? So I did a 4-year bachelor's degree in anthropology. And then I minored in classical civilizations, so like Greece and Rome was still in there. And then I went, and that was at the University of Texas. So I bounced around a lot. I'm from Washington State, but I went to school in Texas for my undergrad my undergraduate degree because they have a really good program in archaeology. And then from there, I got my master's and my PhD from the University of Michigan. So they also had a really good anthropology archaeology program. So I applied for programs all over, but Michigan was a really great program, like a place for me to be at the time. So all told, I did 8 plus 4, 12 years of school. So I did a 4-year bachelor's, and then my master's and my PhD was 8 years total. And then I became a professor after that. And the question was, what education journey does that look like? To be honest, like, I feel like I'm still on an education journey because I learn stuff all the time. Every person I talk to has something to share with me about the Great Lakes that I didn't know. I learned how to surf this weekend. And so I still feel like I'm on my education journey, but to be an archaeologist officially, you have to have a bachelor's degree. So, like, the bare minimum would be a bachelor's degree, so a 4-year degree in anthropology in the United States to do that. But you can volunteer at any time. Um, how do you know you aren't damaging or changing the site? This is a great question. We call archaeology a destructive science because you can't ever go back and like dig it again, right? As soon as you remove the dirt, that's it. So we're really, really careful. We dig very slowly, we excavate very carefully. We take many, 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 many notes. We're always writing notes. We're taking photographs. Now we use drones to document everything we're doing. Underwater, we use underwater robots to document everything that we're doing. So we're very careful. We're very slow. Damaging another thing about damaging the site. So like those pieces of wood that I told you that are on the bottom, like the rooted trees, those, if you bring them up out of the water, they can start deteriorating pretty quick. If they dry out fast, they can warp and the shape changes. So in some ways, in many ways, the best place for artifacts to be is to stay underwater. That's like the best place for them to be. The water is cold, it's fresh, it's this happy little environment for them. It's preserving things. So if we are curious about the past, we take small samples from the wood and we leave the rest of it there to make sure that we're not doing damage to those artifacts. Um, ooh. How big are the ships you work on? So it varies a lot. The Lake Guardian, what's the Lake Guardian, like 110? The Lake Guardian is a big ship. There were like 20 of us, I think, minimum, that were living on that ship for over a week. So that's a very large ship. Probably the biggest ship that I've worked on is like a 200-foot research vessel. Many of the ones I've worked on are closer to 80 feet to give you a sense of scale. But to be honest, all the work in Lake Huron almost all of that happened on a fishing boat, like a 25-foot fishing boat. So the good news about small boats is you can just go a lot faster. So they're like, I'm a boat captain. So I just take the boat. I can just take it when I want. You don't have to schedule time on a big research vessel. So there's some things though that like small boats can't do. Like if you wanted to be way offshore and work in really deep water, you really need a large boat to be able to do that and be in those kind of conditions. But a lot of the work's been done on really small ones. Do I scuba dive in the Great Lakes or just use sonar? I am a diver. I'm a baby diver. So I say that because I haven't been doing that very long. I have open water certification, so I'm certified to dive to 80 feet. I have been on a shipwreck, which is very fun. But a lot of the work that I do when I'm on the boat now, is driving the underwater robot and then doing a lot of the sonar work. But I'm a diver, and I'm gonna get a dry suit certified soon, so then I can go in colder water for longer, which is good. Um, how do you know exactly where to place the ship? Good question. So you first do all of the sonar, right? So you map the bottom. When you're pulling the sonar behind you, it's also connected to GPS, to a global positioning system. So you know exactly where the sonar is. You know where the boat is, you know where the sonar is, and you're kind of like tailing it like this. So when we find something on the sonar, you can go and you put your mouse button there and you click it, and it will give you coordinates to exactly where that thing is underwater. Pretty close, anyway. And then you position the ship over that spot, and then your robot also has GPS on it. So there's a lot of spatial like mapping things you have to know to do underwater archaeology. And you put the ship, the tricky part is you have to get the ship as close as possible without like hitting the archaeological site, right? Because you don't want to drop an anchor over the site and damage it. Like we were talking about, how do you damage, how do you not damage, how do you protect the site? So you get close, but not too close. Most recently, I went out with a colleague and he doesn't anchor at all. he has what's called a trolling motor on the front of the boat. And so it just holds your boat in place without having to anchor, which is great because then you don't have to anchor all the lines in the water, and then it just holds your boat. So it moves you back and forth as the wind or waves are moving your ship. So we use the sonar and the GPS to know exactly where to put the boat. And then there's different ways to keep the boat there. Um, what is the oldest thing you found? Okay, oldest thing we found in the Great Lakes is 9,000 years old. Me, personally. So the oldest thing in the Great Lakes is 9,000 years old. But I have worked on sites that were crazy old. I worked on a site in Spain called Atapuerca, and that was a million-year-old archaeological site, which even for me, like, sounds really neat to say how old it is. That was an early human ancestor site, so that was excavating animal bones and stone tools. So that's the oldest place I've ever worked by far. It was over a million years old, which is so neat. That's our early human ancestors. I worked at a Neanderthal site before, so those are also some of our early human ancestors. That was about 50,000 years old. Oldest thing in the Great Lakes, though, 9,000. Over the summer, I found a really cool spear point in Wyoming. That's about 12,000. So a lot of the stuff I do is really old. Oh, is trash and pollution a really big concern in Lake Michigan? Yes, I think so. So trash and pollution, this is not my specialty, but I'm learning a lot more about it as I work in the Great Lakes. Um, the Great Lake, they're like such a treasure. They're such a treasure for us, for the people that live here close to the lakes, but they're a really important part of like the world ecosystem because they're such large bodies of fresh water. Um, the lakes are like in my experience, they're clean when you're offshore. I pick up a lot of balloons while I'm out there. There's a lot of balloons that make their way offshore that people either get away from people or people release them. So try not to do that. I think it's something that I hope there's going to be more scientists on here that can tell you more about pollution. I know the Great Lakes are getting a lot warmer, and that is creating some issues for environmental concerns. Um, for me, the zebra mussels, I mean, for everybody in many ways, the dracenids, so not just zebra mussels, but the invasive species of mussels in the Great Lakes, um, are a concern. They've changed the ecosystem quite a bit, but they cover all the archaeology, so it's kind of hard to see things underwater. Way more now than it was. But the water's clearer, so there's all these different factors that go into the Great Lakes environment. But trash and pollution, like, let's just all do our part and be really careful. I every time I go to one of the beaches in the Great Lakes, I just take a garbage bag with me, and if I see trash, I just pick it up while I'm there. So that's always like a good thing. I just always have a trash bag in my back pocket. If you're gonna go out on a beach or something, you can just do your part. And if we all do a little, it's gonna make a huge, huge, big difference. Um, what is an overlooked problem you wish people knew more about? Hmm, overlooked problem. I would say, I think knowing that people have been in the Great Lakes for as long as they have, I think people just don't know. Like I didn't know. I know now because I'm an archaeologist, but I think people kind of think that there's history, and there isn't a lot before that, but people in the past were just ingenious. I mean, there were people just like us. They were really smart, they were really creative, they had really important, complex lives, and you can see that through these tiny traces that are left, like small stone tools or animal bones or hunting sites. So for me, I guess like an overlooked problem is I think people just think that people in the past were not very smart or that it was like a really hard place to live. And everything I've always found shows me that people in the past were amazing. Amazing. Like, I don't know anything about caribou and how to hunt them, but people in the past sure did, which I think is neat. You guys, you guys are just back with the questions. It's so good. How do you get things at the deepest area of the lakes to your ship, and how do you keep them from deteriorating? Ooh, once they're in safekeeping. Okay, so to get things from the bottom, if you're going to bring things up from the bottom, how do you get them to the ship? Remember, we keep a lot of stuff on the bottom because that's the best place for it to preserve and to remain kind of in its refrigerated, like intact state. But we do take some samples up. So divers often will go and they retrieve the artifacts themselves in small, like plastic vials, like little, like plastic sample tubes or plastic bags, and they hand deliver them up to the ship. If things are heavy or if they're in different kinds, like sometimes you have 5 gallon buckets on the bottom, you put what's called an airlift bag. It's like you use an airlift, it's just a lift bag. They're bags that you unfurl them, you unroll them, you attach them to something, and you put a little bit of air in it, like, and air expands as it goes up in the water column. So if you're at depth, you put a little bit of air in that bag, just enough for the bucket or the artifact to come off the surface, and then it gets faster and faster and faster. And then it comes up to the lake, comes up to the water level, and then you can reel it in to your boat that way. Um, there's amazing recoveries that people have done with lift bags. So you can look that up, like when they are looking at shipwrecks and they're bringing up like a big anchor, they use lift bags to do that. How we keep things from deteriorating once they're in our safekeeping. So we took some samples of like a peat bog, like PEAT, peat. There's an ancient peat bog below Lake Huron, and we put it in a cooler. So we brought it up from the surface. The divers had it in their hands. They carried it up really carefully, and then we wrapped it in plastic, in like plastic wrap, and then we put it directly into a cooler. That way it stays cool, right? It stays close to the temperature it was on the bottom of the lake. And then you take it straight from that cooler, you get it back to land, you put it in a refrigerator, and then you put it in, you keep it in like laboratory controlled conditions. So that's how we do that. Ooh, yeah. Is there a difference in what you can learn in freshwater versus saltwater sites? You can learn things in all of them. I would say the biggest difference is preservation. So salt water tends to be, not always, I'm going to say water temperature is actually a bigger deal. So lots of places that are really warm, right? That are obviously many times salt water. So if you think of like the tropics or like the Caribbean, warmer water breaks things down faster. So wooden ships aren't as well preserved in warmer water as they are like in the Great Lakes, for example. Salt is very corrosive to metals. So metal ships or like metal cannons or metal guns and things that are on shipwrecks in salt water, they preserve, but they get really bubbly. They get what's called concretion around them. So there's that chemical reaction between salt and metal when the artifacts and the ships have been down there for a long time. We don't get that in the Great Lakes because there's fresh water. So you don't have as much of that chemical reaction as you would in warm saltwater. Um, do you work with human remains or are there just structures that you have mentioned? So I don't work with human remains at all as an archaeologist. I've never done that. I've made a conscious effort and choice not to. There aren't any human remains that are preserved in the work that I have done in the Great Lakes. So just the structures. There might be ancient DNA, which would be great. So because of that cold, fresh water, you have that really good preservation. In the peat bog samples, we're looking for ancient DNA. So there might be traces of human. It would just tell you like people were there. Um, we expected to see you in a white lab coat. See, that's what I thought too. We expected to see you in a white lab coat, probably in like a lab, right, with some chemistry tools in the back. What are some misconceptions about being a scientist? How can you encourage us to try this field? I will say that I had that same one. Like I thought that scientists were just in labs all the time and they wore coats. And I think the biggest thing is there's so many different kinds of science. It's just crazy. I recently met astrophysicists, people who study, the solar system and our planet and our place in it, and people who study deep, deep, deep water and the animals that live in deep water, and marine biologists, and there's people who work with artists a lot in science. And so I would say to encourage you that science is way broader than we tend to think, and any skill that you have, anything that you're good at. If you really like drawing, there's a lot of drawing in science. If you really like writing notes, there's a lot of notes in science. If you like working with teams, there's a lot of that. If you like being outside, there's a lot of that. So you find what you're good at and what you're really interested in, and there's a science for you. You just have to find the right one. I think too, like I have a lot, this is going to sound really funny, but I'm just going to tell you that. Like, I have a lot of stuffed animals in my lab. We try to have a lot of fun in the science that we're doing too. So we take it really seriously. We're doing really important, I think, good work. And we're learning about people in the past. We're sharing about what we learn, about people, how people interacted with their environment, but we have fun too. So I have a big blow up pink unicorn floaty in my lab because science is fun. So I would say that's some misconceptions about being a scientist I certainly had. I thought that it had to be like very serious all the time. And it is. But you can have a lot of fun doing it too. There's like a time and a place for everything. What is the coolest thing that you have ever found? Hmm. Okay. Oh gosh. I have a lot. I think they're all cool. I think everything I ever find is surprising and it's you can't describe the feeling until you do it of like you excavate something and you're looking at a stone tool and you're like, no one has seen this for 12,000 years until I uncovered it. So that sense of joy and discovery like never really leaves you as an archaeologist. Coolest thing recently was a big spear point. It's about this big. I found it, I excavated it in Wyoming, and completely randomly, there's a really neat pattern on it that kind of looks like an elephant shape, which is really cool. I'll put like my Instagram for those of you who have Instagram, in the chat. There's pictures of it on there and all the stuff I found. Um, the biggest archaeological find is all the stuff in the Great Lakes. So everything that we have found in Lake Huron is amazing because nobody had ever looked. No one had ever done prehistoric archaeology in the Great Lakes before. So those little pieces of obsidian and the caribou hunting sites, all of that was a huge deal because nobody had ever looked. We had no idea what we would find. Greatest depth, anything that I have found in the Great Lakes is about 130 feet. So 130 feet below water is where a lot of this stuff is. Um, Oh, this is a good, you guys have such good questions. Um, what's your favorite part of being an archaeologist, anthropologist? Being outside and working with people and then getting to talk to people about what I found. That's three things. I just said three things. Um, I really like working in a team. I really like all the people that I have got to meet. Like I feel really grateful about for all the travel I've got to do. Which Great Lake do you find the most interesting? Is like, whew, that's a hard question. I'm a Lake Michigan girl right now. Lake Huron is amazing. They're all amazing. I love them all equally. But right now, in terms of where my research is, so it's really interesting to me right now is working in Lake Michigan because this is a new lake for me to work in. Um, Besides being cold and fresh, are there any other properties of the Great Lakes that allow them to preserve wrecks and other things so pristinely? Cold and fresh is huge, and then the depth. Um, and as you get deeper, things get more preserved because there's less sunlight reaching those deeper depths, and it gets colder, which is good. So cold temperatures are really great for preservation. A lack of sunlight, really great for preservation. That fresh water is really good. And then to be honest, like there aren't that many people that are out working in the Great Lakes. And that helps preserve things because we're not trying to do like a lot of construction. Like we're not putting a lot of like cables out there or like wind farms or any of that kind of stuff. That helps preserve things because we're not doing a lot of construction work like they're doing um, the stuff in Lake Huron is really well protected and preserved because it's in the middle of the lake. It's not by shoreline where like the waves are crashing against it all the time or people are fishing or we're like dredging it up. So where it is in the lake also helps to preserve and protect it. Have you ever recreated the environment you found an artifact in a lab to help preserve something for study? I would say the closest thing to that is like when we do the refrigeration part. And then we keep things in lake water sometimes. So we'll bring like whole tubs of the lake water up. So it's the same water and then we try to keep it cold to help preserve something for study. Yeah. So we definitely try to recreate the environment. For stone tools, it doesn't matter. Stone preserves no matter where it is, basically. So you don't have to do that for that, but like for the wood, we like keep it wet, we keep it in the original water, and then we try to keep it as cold as it was on the bottom. How do you decide when and where to excavate? Good question. Many times, archaeologists are not the ones that find sites. So in a land scenario, like I excavated a mammoth a number of years ago because a farmer was putting in pipes in his field for irrigation and he hit the scapula, like a big shoulder blade of what turned out to be a mammoth. So he called us, and then that's where we knew where to excavate because he found it first, and then we just worked there. How we know how to do it underwater is by mapping first and mowing the lawn We mow the lawn, we go back and forth, and then we look for what we call targets. You look for interesting things, then you check them out with a robot, and then once you're sure you have an archaeological site, then that's where you excavate. So that's how we decide where to go. How many people are typically on missions with you? How long is the longest trip you've taken for an expedition? Typically underwater for me, it's been a pretty small crew, like 5 to 6. But that is the boat size question, right? Where you guys asked like how big the ships are. The bigger boat you have, the more people you can take with you. Um, on land projects, I was on a crew at that project in Spain at the Puerca. There were 500 people, 500 people that were working at a series of archaeological sites right there. So I've had sometimes really big missions with a lot of people, but usually on the Great Lakes, like 5 to 6. The longest trip I've ever taken living on a boat for like 3 weeks. Being gone on land. It sounds so funny to say land archaeology, but like to dig on land, not underwater. I was on a project once for like 5 months, so that's the longest. Um, this is good. When you're not studying archaeology, what do you enjoy doing? All of the things. I mentioned this previously. I just learned how to surf this weekend. So I'm getting very into that. I ski, I snowboard, I snowboard. I'm gonna learn how to snowboard. I skate. I'm trying to embrace all of the winter sports here because I'm not from the Great Lakes originally. So trying to do a little bit of everything. But surfing right now is really fun. I wanted to do it because when the water is flat, it's really good for science. And then when it's wavy, it's really good for surfing. So I figured that way, no matter what, like if it was wavy, then I could surf, and then if it was flat, then I could do science, and so that way I could be on the lake every day if I did it right. Um, have animals ever made it difficult? Ooh, have animals ever made it difficult for you to complete your archaeological expeditions? I had a longhorn cattle. I worked in Texas for a long time, and so I had longhorns that were pretty opinionated, it's what I would say. So she got a little aggressive. Nothing like totally scary, but we just gave her some space. I've had wild hogs in Texas. Fire ants. We got bit by a lot of fire ants there and snakes. But that's just kind of part of it about being outside, right? Like you are in their house. So you adapt and you're flexible with the wildlife that is there. But yeah, difficult to complete it for sure because that longhorn was standing like over the excavation. So we had to wait for her to like settle down before we kept working. Have you ever felt scared underwater or encountered a scary situation while diving? Yeah. I not scary like it was I was totally fine. But I was really scared to scuba dive, to be honest. I grew up around water, but I wasn't ever like a great swimmer when I was a kid. And I really wanted to be underwater. I love being on boats, like I loved sailing. But just scuba diving for the first time when I had to like jump off something really tall and like get in the water that way, that really scared me because the dive equipment's really heavy and I'm kind of small. And like it just you feel kind of out of balance because the stuff's really heavy and like you know that you're gonna float, but you feel like you're gonna sink because you have all this heavy stuff on. So doing that for me was really scary the first time. And I was totally fine. Like it was a safe scenario. But it made me kind of scared. And I think with diving and anything, like, it's totally normal to be a little scared and to be a little anxious. I mean, I think like we call it having a healthy respect for the water. Like, you got to make sure that you're really safe and you're in a good headspace to do the work and you don't do anything you're uncomfortable doing. For me, science has given me these really cool opportunities to do things. And I kind of encounter that fear and push through and get to these amazing times underwater because then when you're there and you're looking at a fish you're breathing underwater, it's a phenomenal feeling. So yeah, I've definitely been a little scared but have gotten to the other side of it, which is good. um what childhood experience made a big impact or influence in your chosen career path? Watching the History Channel. I this is gonna sound funny, like watching TV, but really honestly, watching the History Channel is what taught me a lot about the ancient world and the past and like what an archaeologist was. I watched the History Channel. That had a huge impact on me. Um, I've been on the History Channel now recently, so that's really cool because it's like a full circle life moment. This is gonna sound funny, but I'm just gonna say it. Honestly, I think The Little Mermaid had a big influence on me and I didn't realize it. She's a shipwreck archaeologist, you guys. If you haven't watched The Little Mermaid recently, like go back. It's great. It's a classic. But she studies people. She's an anthropologist. Like she studies people. She wants to learn about where the people are, right? So I think that movie had this huge impact on me without even realizing it. Because she goes to a shipwreck in the beginning and like she collects artifacts in her museum, right? That's what I do now. It's like it's funny, like how these things happen. Um, what tools can the team use to get certain items out of the ground without damaging or losing them? Tools we use mostly there's like a trowel, so it's like a pointed metal tool that that's used for excavation. I've used bamboo like chopsticks before. We use chopsticks sometimes to like excavate really carefully, and then you can get them out of the ground. Use gloves a lot, right, to make sure that you're not getting anything on the artifact or damaging anything. Really small. We're archaeologists are creative. We use weird tools. Painters' knives. So painters' knives like to mix their paint they have these little plastic tools that are kind of soft plastic. So we've used those before. Um, okay, I'm trying to make sure I get to these. Oh, have you ever experienced Emmett Fitzgerald? Okay. Have you worked with dryland archaeology? Yep. That one I kind of answered this a little bit. Like I've worked on land, mostly in like what we call the Paleolithic. Paleolithic is old stone, the old Stone Age, like the Stone Age archaeology. That's what I do. So I've done that in the place. Um, when you're not in the field, what do you do in your office? Yeah, I write a lot. Well, I teach. So I'm teaching two classes right now at the university. I'm teaching Introduction to Archaeology and then a class about stone tools. And I teach and then I write a lot. We as scientists, you spend a lot of time writing grants. So you write grants to get funding for your research. You write reports about the work that you've done, and then you write up your results in publications, things like books and scientific artifacts, unscientific articles. So there's a lot of writing that takes place in the office when I'm not in the field. Um, what species of trees from 9,000 years ago? The trees are spruce. Some of them are spruce. Some of them are tamarack. Um, any shipwreck discovery favorites? The oldest shipwreck. Okay, so I haven't done very much shipwreck archaeology, to be honest, right? Because a lot of the stuff I do is like prehistory. It's like the much older time period. But I recently went and saw the Senator shipwreck, which you all should look up. It's a really interesting shipwreck that is in Lake Michigan. It sank on Halloween. And there's cars. There's these very old cars that are in it. So that's one of the neatest ones that I've ever seen. If you did not become an archaeologist, what field of science would you be most interested in? I totally just said this to somebody. I think I would do something with space. Um, I'm kind of scared. It always kind of scared me when I was a kid to learn about like black holes and stuff. But I just think that's so fascinating, like about what other planets are like. And the technologies that they use are kind of similar actually to the technologies that we use underwater. So I think I would do something like that. Um, Special gear that you wear while you're on expeditions. There's a lot of special gear for scuba diving. Um, I have a very small little GPS unit that's called an InReach, a Garmin InReach. I always have that thing on me. It's like I clip it onto my person wherever I am. So that way I can talk to everybody if I'm out of satellite service, right? Or if I'm out of like cell phone service. So I always have a GPS on me for safety. Um, what have you found in Germany? So I've worked at a couple sites in Germany that are Stone Age. Stone tools, animal bones. This site had a really cool mammoth ivory carved figurine. So it's like a woman, a Venus figurine is what they're called. But this time in Germany, so I'm going to visit an archaeological site that my colleagues are working on, and then I'm going to a conference. And then I'll be back. Um, okay. Have you ever worked with other well-known scientists? I mean, I think so. I didn't work with him, but I got to meet Bill Nye, which is the coolest thing ever. Bill Nye also, the science guy, he was a big influence on me as a kid. As a student, like we watched all of his shows and got me really into science, and getting to meet him was really, really great. Um, yeah, Germany tomorrow is for that conference. I'm going to a conference and going to visit some colleagues. Um, oh gosh, guys, there's so many questions. I want to make sure I can get them all. Let me take like two more, and then Jenny, let me know if there's anything you want to wrap up with. Lake sturgeon. Ooh, what was it like eating and sleeping on a ship or boat? I feel like Rob could talk on this too. Eating, it's like food tastes so good on boats, guys. Like I think just because you're working so much, and you're working long hours, and it's like so fun that you're on a boat and you can eat anything. Everything they made on the Lake Guardian this summer was so good. We ate really good food. Most recently I went out with my friend, and like we had really good food. We had freeze dried like spaghetti and meatballs on the boat, and we like boiled water and like rehydrated them, and it was delicious. Sleeping on a boat is the best sleep I've ever had in my life. It like rocks you to sleep, right? You're in this nice little like you're in a little like cradle basically. So boat sleep is really good when you're mowing the lawn, when everything's working. And you have like your shift is over and you have another person log in. That's really fun. That's really good sleep too. Lake sturgeon, I've seen some lake sturgeon, not a ton, but we've definitely seen some. Um, have you ever had to say, oh gosh, have you ever had to say no to a project or an expedition? Um, no, but I should. I say yes to everything 'cause I'm excited about everything. But there are some things like you can't be everywhere at once. So as a scientist, as you progress through your career, kind of like where I am now, I am getting asked to do a lot of things, which is fantastic, just because I know more people. But I can't do everything. So you do get to a point where you kind of have to decide like where you're going to work. Summers are short, so you only have so much time off, right? Off. Like I don't technically get paid in the summer because I'm a professor. We get paid 9 months out of the year, but the summer is when I do all my research. So there's times where, you have to pick and choose what you can do. Um, if you could recommend kids partake in an activity to get them interested in archaeology, what might that be? There's this Lego like challenge going on right now. First Lego League. They have an unearthed challenge this year. I think that would be something really cool to look into. Follow some archaeologists on social media and see kind of like what they're getting into. There's a lot of archaeology going on right now. Um, the scariest experience, I've never really had a scary one to be honest, which is good. Like, yeah, it's all fun.